Chalo. So now the first thing you need to remember is the Ohm's law. And Ohm's law basically states that current is directly proportional to voltage if temperature remains constant. So basically in Ohm's law, V is proportional to I, and here we just need to remember when we draw the graph for the Ohm's law, so you can keep current here and voltage here, and this basically makes a line, a direct proportional line starts from 0 and goes through straight, and this is only true for ohmic conductors. Ohmic conductors means that those follow Ohm's law. Okay. Now only two of them follow Ohm's law, like a fixed resistor and a fixed resistor basically looks like this. This is the symbol. So you can write it has a fixed value of resistance. Okay. For example, this is 100 ohms. Then basically comes the variable resistor. So at a particular value, variable resistor also follow Ohm's law. Symbol of variable resistor is like this, and it has a range of values of resistance. That can be independently controlled. What I mean by this is, like, for example, it could be like 0 to 100, there's a range. Usually variable resistors are everywhere. So when you turn on the fan, there is a knob that you turn. So that's kind of a variable resistor, basically. Now, then we have semiconductors. Semiconductors, the first thing is the thermistor. Thermistor symbol is like this. Now, you just need to know that basically thermistor depends on temperature. So if temperature is high, then it has low resistance, and if temperature is low, then it has high resistance. It works opposite. Thermistor is not an ohmic conductor, by the way. So usually the graph of thermistor would look like this. You have voltage, you have current. So, sorry, not the voltage, temperature. degrees Celsius. So it would basically go like this. As the temperature will increase, the current will, the resistance will reduce, so current will go up like that. Now this would be the current versus temperature, but it also can be like resistance versus the temperature. So then this graph would look like this. As the temperature increases, resistance becomes smaller and smaller. Anyway, then the next thing we have is the light dependent resistor, commonly known as LDR. Looks like two lights are being shed on a resistor like this, and this is also non-ohmic. So at high light intensity, a lot of light shedding on it, it has low resistance, and at low light intensity, like in darkness, so it has high resistance. Usually what happens is, Ahmad, I just forgot one thing. The thermistor, common example is it is used in smoke alarms, not smoke alarm, fire alarms. And for an LDR, it is used in burglar alarms and automatic light switching and stuff like that. Is that clear, Hamad?
Yes, sir.
Okay, write it down, please. Hello. ठीक ठाक. कहाँ से? इल्म यूनिवर्सिटी से. जी 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 जी. मैं आपको थोड़ी देर तक कॉल कर लूँ. आई एम इन मिडिल ऑफ क्लास. जी थैंक यू. All right. Now, the next thing is diode. Now, diode is basically looks like this. And you need to remember, if the current goes from this side, so it allows current, but if it goes in this side, it does not allow current. Okay, ma?
Right.
So usually it is just biased in one direction, which means if we get a graph like this, and voltage is here, current is here, and this is negative voltage, negative current. So it would allow current to pass very quickly after a short period of time, about 0.6 volt after this goes up very fast. But on the other side, it does not allow any current. Usually it is used in rectification that we're going to do in A levels, but right now you should remember rectification means that converting alternating current to direct current. That's the main purpose of it. And like LEDs and stuff like that too. Now, yeah, second, please. Now, speaking of this, then the next thing we're going to do is the metallic conductors, like wires, etc. So you need to remember about the metallic conductors that when large current flows through them, it causes heating. Okay. And the reason is that due to increase in temperature, the lattice vibrations increase. This causes resistance to increase. Is that clear?
Yes, sir.
All right, please write this down. Now, the graph of a metallic conductor. Okay, I'm sorry. It looks like this. Current and voltage, negative voltage, negative current. So basically, as the voltage increases, the current increases, and then slowly, because the temperature is increasing, limits the current, like this. And it just goes the same way on the other side as well, if the current is going in the opposite direction. If you have any questions, please let me know.
Okay.
Okay. Okay, now Hamad, any questions? Should I go forward then?
G.
Okay, now so generally when you are looking to measure resistance, before that we need to know the property of a material, which is basically the resistivity. And resistivity is a measure of how resistive a particular material is. So suppose this is a wire made up of certain material. This has a cross-sectional area A, and it has a length L. So what you're going to remember is that resistance really is proportional to length, which means that longer the length, higher the resistance will be. And now the other thing is that resistance is inversely proportional to cross-sectional area, which means that basically greater the cross-sectional area, smaller the resistance. Is that clear, Hamad?
Yeah.
So now what you're going to do is, when you combine these two, resistance is proportional to L over A, and when you remove the proportionality sign, it is rho L upon A. Now, this rho that you see is the resistivity. So SI units of resistivity are ohm meters. You should remember it is a unique value for each material, and of course it is a scalar quantity. Please write this down.
Then does this all the electricity part will mostly contain the IGCSE stuff, or we have something?
Mostly, very little things new. Yeah. Now they're also going to ask you for the power order of magnitude for resistivity, so you should remember this by heart. I'm gonna write some common materials, and I'm gonna write some resistivities of them in ohm meter. So we're gonna talk about silver, copper, nichrome, aluminum, lead, mercury, graphite, germanium, silicon, glass, and quartz. Okay. So to make it easy for you, I just want to tell you that all of them have 10 raised to power minus 8. All the metals have the same, like not the same in exact value, but for all metals the power of magnitude is the same. So this is for metals. Then graphite is a carbon, but it's a conductor. So for this one it is 10 raised to power minus 6. And these two that you see, germanium, silicon, these are semiconductors. So germanium is 1 and this is 10 raised to power 3. So this is the semiconductors. You just need to know power of magnitude, okay? Order of magnitude, that's all. And for insulator it's much higher. So glass is 10 raised to power 12 and this is 10 raised to power 16. And these are common insulators. Will you guys be able to remember this?
Sir, what's the last thing?
Quartz. Let me write it neatly. Quartz. Okay. All right. Now, so generally in these questions, they will give you two kinds of area of cross section. One would be the circular cross section, the other would be the cross section like this. So for the circular cross section, the diameter, and for this one you just need to know the length and breadth, of course. So the formula usually is pi r squared, but we don't use that often for area because then it's basically the same, you can half it off, but generally in ratios we use pi by 4 d squared. That's the formula for area of a circular cross section. For a rectangular one, it's pretty simple. Just multiply length into breadth, that's fine. Now, so these sort of questions are quite, challenging because it requires a lot of ratios. So we're just gonna do few of those, and then let's see, two types, and then so the first one I'm gonna do, and the next one I'm gonna ask you to do. Okay, let me copy the other question as well, so then we can just go in a flow. Okay, now let's look at this question. So in this question it says an iron wire has a length of 8 and a diameter of 0.50. Y has a resistance of R and the second wire has a length of 2 and a diameter of 1. What is the resistance of second wire in terms of R, right? So this is what we need to find. So first of all, I'd like to tell you that what you exactly need is just create a table in the exam as well. Then you need resistance, resistivity, length, area. This is for the formula, and because diameter is given, so diameter is should be there. Now we have two wires. I'm going to write wire 1, write wire 2, and then I'm going to try to solve this. Now see this. It says the resistance of the first wire is R, so I'm going to keep on filling the information. The length is 8 and the area we don't know, but the diameter is 0.50 millimeter, like that. Alright, is it clear? So we should understand that area is proportional to d square, which means that the area will be actually, you can just take a square of the value they've given, like say 0.5 square. This will be 0.25, so I'm going to fill this up. And because they're made from the same material, so I'm going to put the resistivity as the same. Let me show you how. It's resistivity like this. Then what you're going to do is fill in the information that is given for the second wire. So for the second wire, they say that a second wire has a length 2, so I'm going to write 2, and the diameter of 1. Oh, I had to write 0.25. Okay, and resistivity is the same because it's the same material. So now for 1 square is just 1, so I'm going to write 1 here, doesn't really matter. And I want to find the resistance of the second wire in terms of R. Do you guys understand?
Yes.
Now when you have put the relevant information, then you write for wire 1, you could say, because the formula will be R, resistance equals to resistivity, length is 8.0 divided by area is 0.25. And for wire 2, it is going to be R2 is the resistance, resistivity is the same, the length is 2 and the area is 1, right? You got the formula. Now what you're going to do is you divide both equations. So how do we do that? So if I want to divide R over R2, basically what will it be? Rho 8.0 over 0.25 divided, I put this sign, I'm doing it intentionally, you'll know why, like that. So when basically you open it up, this is going to be rho 8.0, 0.25, and when you multiply, change the sign, 1 will go up and rho times 2.0 comes down. So you have to take the reciprocal. Now cancel things out. So rho will be cancelled out with rho. Rest of them you can just do it with the calculator. So it's going to be 8.0 divided by 0.25 and divided by 2. So that's going to be basically 16 actually.
Sir, if we find the area by using the formula pi r square, will we get the same answer?
No, but what is the use? Pi will cancel out, so you don't have to use it anyway. So ultimately,
Okay.
we could say that the answer would be that R will be, R2 will be R over 16, and that's what you needed to find. Hamad, is it clear?
Okay, sir, I'm going to write it down.
Okay. All right. Now, I want you to do the next question, please. And when the meeting ends, you got to rejoin and then give me an answer. Hello, Aman, how are you?
Hi, sir.
Aman, in any case, if Aman, in any case, if you don't receive the link, you just join any previous link. It's the same, okay?
Alright, sir.
Alright, so Aman, I'm just gonna quickly do what we did actually in today's class. You can take the screenshots and then see if you can watch the recording later, okay? So we did Ohm's law, which states that current is directly proportional to voltage if temperature remains the same. And Ohm's law graph is between current and voltage, and it's a straight line from origin, okay? It only works for ohmic conductors, which means conductors which do not increase or decrease their temperature, okay, when the current is flowing through them, which are mainly two, like fixed resistor, which has a specific value of resistance, and the variable resistor, which has a range of resistances, but you can actually independently control it. Understood, Aman?
Yes, sir.
Then we have some semiconductors like thermistor, which when the temperature is high, the resistance is low, and when the temperature is basically low, the resistance is high. So this works opposite to a normal wire. So the graphs actually show that, and the graphs are, you see, non-linear, which means they do not follow Ohm's law, okay? Same goes for light dependent resistor. When the light its brightness, so there is low resistance. In darkness it has very high resistance. Okay, now for diode is sort of a basically component that only allows current to go in one direction. So if it's moving from the direction I've shown, it can go, but if it goes from the opposite way, it does not allow the current to move. All right.
Alright.
Now metal conductors are a bit different. When there is a large current that flows through them, it causes a heating, right? Now this causes the temperature to increase, and when the temperature increases, the lattice vibration within the metal also increases. These vibrations cause resistance to increase. That is the reason that after a while you can see the graph basically like it has a decreasing gradient, because it does not allow more current to flow because the resistance is too high. Understood?
Yes, I got it.
Okay. And then we did resistivity, where I said it's the measure of how resistive a particular material is. Resistance is proportional to length, which means if you increase the length, resistance is going to increase, but it is inversely proportional to cross-sectional area. So if you decrease it, if you increase the cross-sectional area, the resistance is going to be lesser than. Now the formula that basically relates them is R equals to rho L upon A. This rho is the resistivity. Its SI units are ohm meters, and it's unique for each material, and of course scalar. Now in the exam they might ask you directly about the resistivity, order of magnitude of resistivity. So you should remember all metals have 10 raised to a minus 8. Graphite, which is a conductor, but it's made of carbon, so it's 10 raised to a minus 6. Germanium, silicon semiconductors, they have 1 and 10 raised to a minus 3. But then glass and quartz, because they have basically their insulators, their resistivity is very high, like 10 raised to a 12 and 10 raised to a 16. Understood?
Okay.
So usually they would give you diameter. That's why I've given them the formula that to find cross-sectional area, you have to do pi by 4 d square, and for if it's a rectangle or square, so you have to do length into breadth. Then we did this question where basically if it's a ratio question, you need to make a table, right? Like for example, it said an iron wire is the length, right, of this, and they're made from same material, whatever. So the things we need in this is resistance, rho, L, A, and D is given, so we included that. So wire 1 was like, you see, they said it has a resistance R, so I wrote R in green, and then resistivity is rho, length was 8, area, diameter 0.5. Now because area and diameter are related by a square function, which means area is proportional to d square, so 0.25 would basically cause area to be 0.25 of the area. Do you understand? Like that. And then similarly I did it for the other one as well. Now the idea is that you write the equation for both and then you divide them. Like I wrote R for wire 1 and wire 2, and then I divided both, and then I put this sign. If you see this sign, the reason is that when I remove this, it will cause the other side to be, you have to take a reciprocal, right, to go upside down. Do you understand? Now
Yes, it just cancelled over there.
so then you can cancel out, and then we got R2 is equal to R over 16. That's what the question was. Now we are doing, a pencil is used to draw a line of length 30 centimeter and width of this. Resistivity is this and resistance is this. What is the thickness of the line? Can you, have you guys done it?
Yes, sir.
Answer please.
You mean the second one or the first one?
First one I already did it. Second question. Hamad, answer please.
सर मैं पहले कॉपी बस हो गया और कुछ बाद
Go on.
क्वेश्चन में कॉपी डालता हूँ
By the way, I sent you a worksheet. Why is it not done? Aman, where is your worksheet?
So I'll be sending that in tonight. It's almost done.
Okay. Aman, 5 days for 6 pages. That's not good.
Yes, sir. Sorry.
Okay, now for this question, remember they're looking at a pencil line, which means if it's talking about length, width, and thickness, it must be a cross section of something like this, right? So it's saying this is basically the cross section. The length of the line, let me draw it with another color. So the length of the line is given as 30 centimeter and the width is 1.2 mm and you want to find this thickness, right? This thickness. Now again, for this you need to draw you need to put a table, right? Like this. Resistance they have given as 40 kilo, which is 10 raised to power 3. Resistivity is 2.5 times 10 raised to 5. Length is 30, you have to convert it into meters, and area would be what we need, right? Because we want to find thickness at the end. So now when you use R equals to rho L upon A, so area is going to be 2.0 times 10 raised to 5 resistivity, length is 30 times 10 raised to minus 2, and resistance you got to multiply, divide, like this. This basically makes it 1.50 times 10 raised to minus 10 meters square. You can actually find it yourself as well. And then because area is basically width times thickness, so we got the area. The width is 1.2 millimeter. Millimeter means 10 raised to power minus 3, and thickness is what we need. So thickness should be 1.25 times 10 raised to minus 8 meters. Is that clear, everyone? Alright, please copy this down. Now for tonight everybody must complete the work, because tomorrow I'm going to check that first and then I'm going to continue, because this chapter, like the resistance and resistivity, is also finished, right? Because there's small topics within the whole electricity chapter, so it's just one class chapters every day. So make sure that you complete that worksheet so I can give you this worksheet today. That was my initial plan, but now you guys are feeling on it, that's why. Alright, see you then. Bye. Have a nice day.